main course of the day, okay? And that's going to be mass. What is mass? My God. And that's continuing with what I started the other day. We've been looking at mass and gravity and black holes and so on. So let's look at this. Here we have some of the questions, some of the comments people made since I put these shorts out, started with the shorts. And here it is. So it says, describing black hole as infinitely dense and infinitely small is an incorrect concept to explain black holes. Okay. And he says, I have come up with a better way of understanding dynamics of black holes. Okay, let's see. Black holes, I believe, are objects that are so heavy that they crush themselves into a smaller and smaller object, unable to reach its smallest point because there is no smallest point that matter can reach. According to what? The laws of the dimensions. Laws of the dimensions. What is he talking about? But this is what he's talking about as far as, becoming smaller and smaller and never reaching a smaller size, right? And there it is. That's illustrated there for you. What they're saying is you're falling to a point, right? But you never reach the point. You're traveling forever. It's infinite, as they call it. That's the word the mathematicians like to use, infinite or infinitesimal, right? You're approaching the so-called singularity, but you never make it there. You're always falling. Why? Because what do you say? The laws of mathematics are what? Crushed out of existence at a singularity. The equations are crushed out of existence there. So, you can't get there because it's very dangerous. You'll be crushed out of existence. But fortunately, you never make it there. So I guess you survived the trip because you travel forever. So this is quite a bit of nonsense. But this is what they're talking about. They're saying, look, it becomes smaller, smaller, and smaller. You approach the singularity, but you never make it there. And the laws of physics break down, and all this nonsense terms that they've created, all these people just parrot. They just memorize and say, but the laws of physics break down. Whatever nonsense that means. It means infinity. That's what it means. Infinity means that you travel forever, And in the case of black holes, that's a serious problem. It's a fatal problem because it means that all the matter is still inside the black hole. So they have a contradiction. On the one hand, they say all matter is crushed out of existence. That's what half of the mathematicians say. The other half say, well, no, you don't really get crushed out of existence because you never make it to the singularity train station. The train station's there and you're always approaching it, but you never make it. It's like the Achilles and the turtle thing, where he only travels half the distance and half the distance, half the distance, half the distance. And he's always half a distance away from the train station, the singularity train station. And that's where the problem is. This is irrationality of mathematics. It has nothing to do with physics. Physics, we don't have something called singularity, or that you approach a location and never make it there. No such, unless you die. But your body maybe makes it at least, dead. But, there's no such thing as not being able to approach a location. And what these people say is singularity is a location, a place, a position, or whatever you want to call it, a little space, a region, and you're always approaching it but never make it there. And that's idiocy. That's mathematical idiocy from Cambridge and Harvard. That's what it is. Okay, so what are these laws of dementia? Let's see. This guy says laws of dementia. And I looked at some of the things he wrote. Transfer of information. He transfers information. And information the wave carries. A wave carries information. And he says something about dimensions being related to temperature. What does temperature have to do with dimensions? I mean, this is dementia. That's what it is. Total dementia, what he's got there. And talks about energy, potential energy within, mass, fabric of space. What is that? What space? Space is nothing. There is no fabric. But these people talk about the fabric of space-time, of time, of absolute nonsense that they've fed these people in their heads, and they just, tiny brains couldn't not absorb all that information, blew their brains out. So they talk about fabric of space and energy and what space stretching. They're going to stretch nothing. Okay, good. Good luck with that. You'll spend the whole day just stretching nothing. Okay, that must be a lot of fun. Okay, so here we have another one that says black holes have been proven multiple times to exist. Of course, he doesn't know what the word exist means, so he just uses it. He says it exists, whatever that means to him. Just look it up, okay? Where are his examples? My examples. Where's his proof? He looks for proof, evidence. He wants me to convince him, persuade him, recruit him. No, we don't do that in science. We explain a mechanism whether you believe it or not. We don't twist any arms, okay? Blurking out faster with no context or explanation. He says black holes have no mass because of what? They are zero-dimensional. Exactly. If it's zero-dimensional, there's nothing there. Zero-dimensional is the definition of empty space, of nothing, of vacuum. That's what zero-dimensional is. Zero volume and zero matter, because they say black hole crushes all matter out of existence. There's nothing there really between the singularity and the event horizon. So what do we have? We have absolutely nothing. So they say, well, but it has mass. What do you mean it has mass? Mass is the quantity of matter, right? And there is no matter. It's been crushed out of existence. So you don't have any mass either. But even if we concede all that, let's concede that it's got mass, it's got tons of mass, gazillions, infinite mass. I don't care. You put as much mass as you want, okay? Listen carefully now, okay? You got all the mass that you want, okay? Just put a number there, whatever satisfies your strange feelings, okay? So you have all this mass. How does that mass physically compel a star to move around the black hole? That's what you got to answer. If you can't answer that question, you got garbage in your head. Okay? Don't tell me that mass moves a star around. No, mass cannot do that because mass is a mathematical concept. You have to tell me the physical mechanism. How does that famous mass, whatever that is, right, move a star around? Okay? What these people are saying is that there's an influence there. Yeah, you got to tell me what the physical entity is, what the mediator is. If you don't have a mediator, you cannot explain rationally how a black hole moves a star around itself. Okay? What you're saying is mathematically, look, mass moves so far away, another mass. Mass times mass divided by distance squared, blah, 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 right? No, that's in math. In physics, you got to show us a physical mechanism. You got to show us some mediator, something that we can see or touch, right? That's what people say that a physical entity is. So show us what we can feel, what we can see or touch, what we can feel, what we can run an experiment with or whatever. Okay, what do we have between the black hole singularity or the black hole event horizon or black hole whatever and the star? What's between that? That's what we want to see. Okay, put something there. You can't put anything there, you got nothing so far. You can't say, oh, mass moves a star around. That's idiocy. It's called idiocy in physics, okay? Okay. So here we have another fellow. He gives it his best shot. He's saying black holes don't have mass is ridiculous. Oh. Okay. They exhibit extreme gravity, so we don't know definitely that they have mass. Okay. And so what is this mass that they have? Show us. Show us a picture of this mass that they have. What is it that they have, right? Says it seems to. He seems, referring to me, he seems to be arguing that black holes have no mass because they are zero-dimensional. Yeah, and then he says none of these claims are true. That it's not zero-dimensional, and all mass has been crushed out of existence, right? So all matter has been crushed out of existence, so it has no mass. It has no dimension, so obviously we are talking about nothing. Okay, so far we have nothing in front of us. And he says, however, the nature of a singularity is not well understood due to the breakdown of current physical theories at that point. Okay, so he's saying he's just repeating stuff that he heard out there that the mathematicians, people like Brian Greene and Neil Tyson, all these people feed garbage to the public, and these people just swallow it. They never criticize it. They never question it. They say, oh, what a genius Tyson is. What a genius Brian Cox and Bill Nye are. They're such geniuses because they do all this math. They went 10 years to college and they learn how to do all these equations that these people don't understand. And so they say, oh yeah, it's got so much mass. Then they were questioned, what is this mass? what is it? This mass that moves stars around, that compels them to orbit around the black hole, this center called the black hole, this singularity, and by what mechanism? And they never asked these questions. It never even crossed their minds to ask these questions. That's what you got to put them on the spot. In fact, I will be putting them on the spot today. You'll see towards the end. Okay, so here we go. Where did I get all this? He says, where did I get it? I just came up with this out of the top of my head. No, here it is. Okay, listen carefully. This is one of your gurus, Hawking. Stephen Hawking. You know who Stephen Hawking is? Guy who died a few years ago, and he talked a lot of nonsense, more nonsense than anybody else. But this is one of the things that he said. Okay, this is in his book, so you can look it up. I didn't invent this. Here it is. He says, Eddington was shocked by the implication, that a black hole would collapse to infinite density. In other words, a star would collapse to infinite density, meaning a black hole, right? And he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse, what? To a point. Point, dot, no volume. That's what they mean by point. Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. Do you know what zero size means? Zero size means nothing. Zero size is zero dimension, zero shape, no volume, okay? Zero radius, zero diameter, zero whatever, all the zeros. Whatever other zero you can think of, that's what is a black hole. So it's 0, 0, 0 all the way, and if it's got zero matter, because all matter is crushed out of existence, it's got zero mass. So yeah, I didn't invent all this nonsense. It was invented by idiots like Stephen Hawking and Einstein. Well, Einstein was against black holes, but a lot of people don't know that. But Chandrasekhar, Arthur Eddington, all these people is the ones who gave us all this nonsense, okay, about black holes and so on. You have other people who came later on, Hawking himself, Penrose, and so on. And in fact, Penrose won the Nobel Prize a couple years ago because of black holes. And all these people created this black hole nonsense, and all these people just believe it. They say, the black hole. Yeah, what is a black hole? Please draw it for me. And he goes, they took a picture of it. What did they take a picture of? If it's zero dimension, they're telling you, zero size. How can you take a picture of zero size? Please come down to earth, bean brain. Okay, so yeah, they have all these notions that these mathematicians fed to them, and they never questioned it. They said, Stephen Hawking, he must know. So what Stephen Hawking did was put his brain in the heads of these tiny little brains that these people have, Okay, so here goes. Well, it says, if black holes don't have mass, then explain how they have gravity. Okay, I'll get there in a second. They have mass, they have gravity. Let's see what else they have. Okay, he put a comment, this fellow put a comment a short while ago. I got it at the last moment, so I put it up here. It says, can you tell me how black holes are formed? Making statements that are literally the opposite of what? The scientific consensus. Scientific consensus, scientific they call it. Yeah, black holes are scientific, sure. Your insistence that black holes are literal singularities and therefore can't exist is an indication that you're the one taking abstractions too literally. So he recognizes it's an abstraction, and he says that I'm taking this abstraction and I'm the guy who's at fault because I'm turning the abstraction into something solid, into an object, into a thing that we deal with in physics. Physics only deals with things. Okay, only with things. You have to have a thing to have physics. No things in the universe, nothing, no physics. There's nothing happening, nothing going on, nothing to measure, nothing to test, nothing to experiment on. You're not watching anything, but there's nothing there. You have to have things in physics. Physics starts with objects. You have to have an object. And these people talk about abstractions. You say, I'm making the abstraction into a physical object. These people are saying a black hole moves a star around. It had better be more than an abstraction. You had better make it literal. Okay? It had better be literal that a black hole has something there. And he says it does. It has mass. Yeah. What's mass? Mass is what? A physical object. I can hold mass in my hand and say this is what is inside a black hole. All this masses, all these masses, all this mass. No, you have to have a physical object. Black hole is not a physical object. In fact, it's not a physical object under the scientific definition of object, which is that which has shape. It has no shape. Zero volume, no shape. Zero dimensions, no shape. Okay, and it's not an object even by the definition that mathematicians use, which is see and touch. You can't see it, you can't touch it. So far, a black hole is not an object, not a thing. And he's saying I'm turning that concept, which they call mass, into a physical object. No, you're doing it. You had better do it because it has to be literal. Physics is literal. You can't use abstractions like, black hole singularity and say a singularity moves a star around. That's where the problem is. It's a semantic problem. It's a problem with them trying to give a physical interpretation to their mathematical equations. And of course, they're going to bomb out. They can't do that. They can't give a physical interpretation with this nonsense. Okay, so here are all his irrational statements. I made a list here, a small list. In physics, it's irrational to say that you have a headache. Okay? You can't say in physics that you have a headache. Okay? In physics, you can say that you have a dime or a dollar in your pocket, but you cannot say that you have money in your pocket. Okay? In physics, you can say that you cast a gold coin into a well. It is irrational to say that you cast a Bitcoin into a well. Okay? I hope you're following along here and understand what's going on. It is irrational in physics to state that you sent or received information, or to say that information travels or was destroyed. These idiots from math, they say that information was destroyed inside a black hole. Information was destroyed, yeah. It is irrational in physics to say that a black hole has gravity. Gravity is a concept. You cannot have gravity. In physics, it has to be an object to go with the word have. The verb have cannot be used with concepts. Okay? And so all these people are talking idiocy because they learned the idiotic language from mathematicians. And so they say, oh, I have a headache. No, you do not have a headache, not in physics. In physics, you cannot have a headache. Okay? You can have a head, but not a headache. And likewise, in physics, it is irrational to say that a black hole has mass. What is mass? I mean, is there a physical object that called mass? What are you going to show me? What is mass? Mass is a concept. You cannot say I have a concept. Not in physics. In ordinary speech, you can say you have love, you can have intelligence, you can say whatever you want in ordinary speech. In physics, you can only have objects. And black hole is not an object, not a thing. And if it's not a thing, it cannot have effects over other things. Like, move stars around itself, a black hole, Okay, so here, let's continue. We have this. There was a program in the 60s that I watched, Cowboy. And it went like this. The name of it was Have Gun, Will Travel. Those of you of my age know what I'm talking about, probably, because it was a quite popular program. Have Gun, Will Travel. And you can see what these guys have in their hand. Those are called guns. Now, a mathematician would not understand it, so I had to write to the people in Hollywood and ask them to change the title, because all these mathematicians were not understanding even the title of the program. And so this is what they changed it to. This is the new name that they have today. It says, have mass will travel. That they understand. But if you say gun, a mathematician will not understand, because gun is a physical object, and they don't understand what physical objects are. So if you say have mass will travel, they understand that. They say, okay, I see. So in physics, or in mathematical physics, in the religion of Mathphyz, right, you have to have concepts. You cannot have objects. Okay, you can have a concept and then you can travel. Otherwise, if you have an object, they don't understand what you're talking about. Okay, you have to have concepts. And this is where the problem is. It's a severe semantic problem. The mathematicians haven't defined any of their concepts. You ask them, what's mass? We don't know. What's time? Well, we don't know. We're still searching. We're still doing research and development. You ask them, what's a black hole? We don't know. Singularity, we don't know what's there. The laws break down in there. And so on. They don't know what energy is. They don't know what field is. Field is a bunch of numbers, and then they use it as a physical object, and so on. So they have all this language that they created, irrational language, which they teach everybody in high school and later on in college. And people just swallow it. They just talking, oh, the energy, oh, the field, oh, the wave, the ether, and so on, the space-time. They take it for granted. All these words are known, that we know what they are. And this is where the problem is, that none of these words belong in physics. None of them. In physics, you have table, you have chair, you have rock, you have tree, you have dog. Those are words that belong to physics. Words like field, energy, mass, force, time, none of those belong in physics. They have nothing at all to do with physics, because in physics we have to give a physical interpretation. Okay, so here it is. We have 7 definitions of mass today. This is according to the Wikipedia. They put 6 out there. And the first problem there, as I talked about the other day, they're operationally defined. And that's a no-no. That's an irrational definition if it's operationally. Operationally or functionally is, functional definition. Those are irrational definitions. The person talks all day long, his dissertation, he gives a presentation, and at the end of the presentation he says, let me tell you what I was talking about all this time. And that's when he says it was defined by all the stuff that I said. So that's the definition of whatever he talked about, And so that's the problem with mass. It's defined operationally or functionally, and that's irrational. And they have all these different definitions. One where it's resistance, inertia. Another one where it's weight, a synonym of weight. Many mathematicians want to deny that, but it's true. There they have it. Gravitational mass, measure of strength of an object's gravitational flux, and that's weight. And then you have rest energy, which is quantity of matter. And they call it rest energy or rest mass or whatever, and what they're talking about is, the object there, what are we talking about? It's not moving. So what we're talking about is the quantity of matter, how many atoms it's made out of. Okay, so yeah, they have all these different notions, and that's why they can't tell you what mass is. And, they have all these definitions. They say a black hole has mass. Well, which one of them? Does it have gravitational mass? Is it inertial mass? Is it, static mass, another rest mass? What kind of mass does it have? We have all these color masses, the red, the blue, white, and blue mass. We need to know if it's red or white or blue, You got to tell us. What mass does it have? And so here's the 2 primary ones, okay? We have the quantity of matter, which is the rest mass, and it involves counting, okay? We need to know how many atoms form an object when it's standing still, when nothing's moving, when you're not comparing it to anything. We just need to know how many atoms are in that stone or whatever you have in front of you. And in this case, we have 1 trillion atoms. And that's the way you would have to specify the mass according to the definition of quantity of matter. If it's quantity of matter, you have to specify it in number of atoms or number of units of mass, whatever unit you choose, and you say, well, this one has 1 trillion atoms. Okay, we all understand that. Okay, it means that if you were to count all the atoms that make up this object, you would end up with 1 trillion atoms, right? And on the other hand, you have this other one, which is gravitational attraction or inertia or all these other dynamic masses invented by the mathematicians, right? And this one you weigh. You have to push it against something, right? Or you have to speed it up. You have to run it at the speed of light or close to the speed of light. And here, this one weighs 1 gram. So the question is, which of these 2 notions are we going to use? Are we going to use the quantity of matter or the weight, what I call weight, which is the 1 gram, you weigh it, right? You take it to the moon, you weigh it. You take it back to Earth, you weigh it. That's how you determine the mass. And they say, well, no, the mass didn't change. What changed was the weight. Yeah, but so did the mass, because the way you determine mass is by weight. So, yeah, mass and weight are exactly the same until you can figure out how to separate them. Right now, they don't even understand the difference between counting and measuring. Because if mass is the quantity of matter, you should express the result in terms of atoms or units of mass, whatever unit you decide to use. Okay, so that's where the problem starts. And because of this, you have all these great men of science like Neil Tyson who cannot explain anything. And they cannot explain for sure gravity. They haven't been able to in thousands of years. And here you have the simplest thing in the world, gravity. I mean, here it is, gravity. Okay, watch it very closely. You let go of the pen in this case, right? And it falls to the ground. That's the only experiment you ever needed. Now we need to explain it. Why does this pen fall downwards? That's what you need to explain. Okay, and they cannot explain that. They say, look, I can tell you how fast it travels and how warped the space is here and all this nonsense, but they cannot tell you what caused it to come down. Something so simple. I mean, this is as simple as it is. Okay, very simple, baby stuff, kindergarten stuff. And here, let me bring Neil to tell you all about it himself. Okay, so give me a second here. Here it goes. Listen to him carefully, okay? This is Neil Tyson, okay? Here it goes.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. Gravity is the curvature of space and time, and you're moving on the curvature of that fabric. That's gravity. I can describe what gravity is doing. I even have a mechanism for it. You say, why did it fall? I say there's a force of gravity operating on it. Why did it fall that way? Because of the curvature of space and time. I'm answering your whys. Then, well, why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
Okay, so what does Neil say? He's working on it. He's still working on it. And they're going to work forever because they're trying to give you a physical interpretation, but they can only give you a mathematical interpretation, and they can't turn that into words. They can't turn their quantities into quality. Quantitative into qualitative, right? They can't give you a qualitative physical interpretation of how gravity works. And they never will. They never will because it's not in their line of work. They don't do, I mean, they want to understand gravity, but they'll never understand it because they think they're going to approach it through math, through some kind of equation, you know, and they say, let me develop the equation that tells us what gravity is. And they never will. I mean, already Newton gave us the equation, mass divided by distance squared. Okay, there's the equation. That's all you needed. You know, here you have, again, the pen, and it's pulled by everything on Earth, okay? And so the question is, you know, you have this mass, and you have the mass of the Earth, and you have a certain distance. The closer it gets, the faster it goes, right? We've all experienced that, you know, at home and everywhere. And so we already have the equation. We already have everything we need to know. We just need to explain it now. And these people cannot explain it. Why? Because they never identified the invisible, intangible objects that are in contact with a pen. And so they say, well, there's nothing there, Bill. Yeah, because they think that an object is that which you can see or touch. And they say, I can't see or touch, so there's nothing there. No, there is something there. There had better be something there. Otherwise, you're doing witchcraft. You're doing black magic. You're doing voodoo physics. Okay? That's, if you don't put anything there, you're doing voodoo physics. Okay? And so this is why Neil has no clue whatsoever. He never will, because he's not a scientist. He's not a physicist. What he is a clown. And I'm not offending him. Okay? He is a clown. He's in the entertainment business. But people think that he's a scientist, that he's a physicist. No, he's a clown. He's a buffoon. He's trying to make you laugh. He's trying to entertain you. That's what he does. Okay, so people get the wrong ideas about Brian Greene, Neil Tyson, Brian Cox, and all these people who are out there. They're out there to entertain you, not to educate you. And people come to their program and say, oh, I got my shot of science for the week. No, what you get is a little entertainment, that's all. Distraction. And so this is the reason deGrasse cannot tell you anything. He says there's a difference between how and why. And he never understood that. He doesn't understand the difference between description and explanation. Okay? And how is a description? Why is an explanation? A cause. The mechanism. Okay? Neil states that mathematicians who call themselves physicists are satisfied with descriptions. He says that, and then he tries to explain. He says they're satisfied, but they're not satisfied. Okay? I'm going to try to explain. What does he say? He says that gravity is the warpage of space. Well, that either he's very ignorant, extremely ignorant, or he's trying to wing it. He's trying to pass one through you. You cannot say that here in this region space is warped. Not the field equations that Einstein uses. They only work out there. They work out there in the cosmos. They don't work here at our level. That's why quantum mechanics cannot explain, gravity. Because if general relativity could be done here at this level, hey, then we wouldn't need quantum gravity at all. because we would have an explanation for why this pen falls at this level, or an atom falls, or whatever. You know, it doesn't, anything here on Earth we would be able to have an explanation for. You cannot say that space is warped here so profoundly, like in a black hole, that this falls, you know, like it falls at 9.8 meters per second squared. Okay, you cannot say that. And these people don't understand. So he gets away with talking nonsense. Neil should know, if he studied 10 years at the university and got a PhD, he should know that you cannot apply general relativity at this level. And so he's lying, or he's ignorant, one of the two, okay? And he says they can't explain causes, but then he tries to explain. He says we can actually explain why. He says that to you. And what is the cause of gravity? Warp time. What kind of answer is that? Warp time? That time is warped, that you have this wall of warp time, and that's the reason the Earth doesn't fly out of the solar system, because time is warped. There's a wall of time. And that's when these people say, oh, Bill, you're taking the abstraction too literally. Yeah, tell me about it. I mean, it had better be literal. I mean, you're telling me a mechanism. You're saying the reason the Earth doesn't fly out is it's in this depression in a bunch of number lines. And one of those is time. It forms a wall. It's in this depression. And that's why the Earth doesn't fly away. That's not an abstraction. You're telling me a mechanism, and you're explaining your mechanism, you know, objects, and you're explaining them with an abstract concept called time. That's what you're doing. And these people don't realize that. And why does mass warp time downwards, Neil? And he said, we're still researching. Yeah, he never will explain why. In fact, he's using gravity to explain gravity. He's saying, you know, the reason something is warped is because you're weighing it down. And that's Newton's force. And I thought Einstein's field equations destroyed Newton's force equation. So we need a force to create the depression. And then he says, then gravity works. Oh yeah, but you needed a force to create the depression. So, okay, so what is it that we do absolutely need to explain gravity? Here we'll have Richard Muller, another teacher, professor, instructor at University, Berkeley, I think it is. And he's going to tell us what you need to explain regarding gravity. Listen carefully. He's telling you exactly that the following. He's saying that every atom on Earth is bound, is tied, is connected, physically connected to every atom in your body, or every atom on the surface of the Earth. Here it is.
If you have the Earth with its big mass in it, and you have you with your little mass here, that every atom on the Earth is pulling on every atom of you. You're also pulling on it. You're pulling on atoms right now on the other side of the Earth. On the other hand, there are a lot of atoms here you're pulling on. You're pulling on all of them. The amazing thing about gravity is it goes right through things.
Okay, we got that. Every atom in your body is pulled by every atom on Earth. Every atom on Earth is being pulled by every atom in your body. How do you pull unless you have an elongated object such as, in this case, a rope? Maybe it's a string, right? I don't care what you use, but you had better have an object. Otherwise, how do you pull? How do you pull on the donkey if you don't have some mediator, a rope or a wire, some elongated object? How do you pull? That's what you got to explain. And are you going to pull with mass? Is that what you're going to pull with? You're going to pull with force or with energy or field? What are you going to pull with? And so you have to identify the object. And there had better be an object here when this thing falls, right? There had better be an object, or here, wherever, I don't care. You can say a lot of particles are pushing, fine, because they're touching the pen. Or you can say something is pulling, which is the case with Richard Muller. He says something is pulling on every atom of the pen. How do you pull without a mediator? Okay? And people don't understand physics. They want to do math. We don't care about math. We want to know the mechanism, the cause, okay, the physical interpretation for why a pen falls to the ground. And he's telling you every atom of the pen is bound, is connected, is being pulled by every atom on Earth. there had better be an elongated object that we cannot see or touch that binds every atom on Earth to every atom of the pen, or of you for that matter. Okay, so this is what I call it now. Here it is. We changed the name. It's called Mathematics, or because there's a lot of semantics there involved, right? Or you can call it Mathemassics. Mathematics. And yeah, they say a black hole has mass. Mass pulls on a distant star. All that mass falls into a singularity, but we don't know what happens there because the laws of math are crushed out of existence. It's like asking, what's north of the North Pole? This is what people swallow, this stupid idiocy, these cliches that they've invented. What's north of the North Pole? Well, hopefully there's something like, Polaris or a star out there, maybe Andromeda. To say that what's north of the North Pole. They get you with all these, and people suddenly, and they say, oh, what's north of the North Pole? Oh, that went over my head. I got to think about that. And meanwhile, the guy wanted a conversation. Yeah, another sucker bites the dust. And he leaves laughing at you because you're saying, oh, you swallowed the expression. Oh, what's north of the North Pole? What could it be? They get all these people, these morons, with these cliches. It's so easy to convince them. And it's all on the basis of authority.